Okay, so we are going to continue looking at differential equations, and what we focus on in this tutorial is just these questions where the question is asking us to find a particular solution to each ordinary differential equation that is given. So the question that we have does not really specify which method that we are supposed to use, and there are several methods that you can use, and it all depends on the nature of the differential equation that you have. It's not every differential equation that you can use separation of variables. It's not every differential equation that you can use maybe variation of parameters or indeterminate coefficients. It's just a matter of us knowing what kind of differential equation that we are dealing with. Remember to say we have homogeneous differential equations, non-homogeneous, we have linear, non-linear, so on and so forth. So as we go through these questions, we are going to be finding out, we are going to be learning the tactics that you're going to be using as we approach these such questions. So looking at the first one, where we have uh, dy dx plus y over x being equals to 0. Okay, so for this one, you can observe straight away to say this is just in the form um, dy dx like being equals to f of, let me say, f of y by let me say h of x. Okay, so now we observe to say if it's in this form, we're able to use separation of variables, and I believe this is a very straightforward one, whereby we're able to write it in the form dy dx is going to be equals to minus y over what? Minus y over x. To simplify this, or to write it in the form that you're supposed to write it in, whereby you are going to have like the integral of 1 over f of y dy is equals to the integral of g of x dx, according to when it's given as dy dx is equals to f of y by what? G of x. Okay, so this is a condition that's supposed to be satisfied when we are dealing with separation of variables. So what I'm going to do right here is that I'm going to multiply both sides by 1 over y. I also multiply both sides by what? By dx. Alright, so what are we going to have right there? So this is just going to be like the integral of, if you multiply both sides by 1 over y, you're going to get 1 over y dy is equals to, multiply both sides by dx, you're going to have minus the integral of 1 over x dx. Okay, so now we can go ahead and integrate this. This is just simply going to give us ln of y. Okay, ln of y is equals to minus ln of what? Ln of x plus a constant, but that constant I'm going to present it as ln of what? Ln of c. There is no harm in you presenting that constant as c. C and ln of c are simply one and the same thing. Okay, so here I'm going to say ln of y being equals to, I'm going to write this in the manner ln of c minus ln of what? Ln of x there. Okay, so we observe to say we know the properties of logs, whereby our ln of y can be written as ln of what? C over what? C over x. Okay, due to the properties of logs, where if they are if they're subtracting each other, the negative one becomes the denominator, the one that's positive becomes the what? The numerator, and that's what we have right here. We have c over x. And from properties of natural logs, again, we observe to say here our y is simply equals to what? Simply equals to x. You might want to see it as if we are cancelling out natural log and natural log there, but that's not really the case. Let me show you how it comes about. Of course, we have done that several times, but I'll talk about it anyway. So what it is that you have natural log of y, which is simply um, log base e of y being equals to what? Log base e of what? Log base e of c over what? C over x. I'll write it in that manner without absolute symbols. It's fine. I just want to explain why it comes to this, and the fact that it's not really straightforward that you're just cancelling out like that. So now what it is that what we are saying is that our e, okay, our base e raised to that is equals to y. So what it simply means is that you have your y being equals to your e, okay, your e raised to the power log base e of what, c x, like that. So you observe to say you have e here and you have your e there, giving you what, y is equals to what, c over x. Okay, that's what we have right there. And relating this to that, we see it a lot. Like for example, when you're talking about natural log of 0 being equals to 1, how does this come about? You simply say no, it's the other way around. Natural log of 1 being equals to 0. How, this is how it comes about. You say log base e of 1 is equals to 0, and it's true. What you are simply saying is that you are saying e to the power 0 being equals to what, 1. So those are some of the few tricks about how natural, or let me just say, logs work in general. Okay, so in this case, this is the general solution. I want to find a particular solution. For me to find that particular solution is that I've been given these points. I have my x equals to 2 and y equals to 2 as well. So I can come here and say, okay, I have y as 2, I have c, then I have x as 2 here, then I have 1 here. I can do the cross multiplication. So I'm going to have my c being equals to what, being equals to 4. Therefore our particular solution is just y is equals to 4 over what, 4 over x, and that is that. So let's go to the next one. So the next one is where we have our 2 x plus 2y dx plus y minus x dy is equals to 0. And we are told that given that x is equals to 1 and y is equals to 0, but we want to make use of that when we'll be about to find the particular solution. First of all, find the general solution. And looking at this, without even wasting much time, I observe to say I can also write this in the form dy dx is equals to like f of x, let me say g of y, like that. So this can be, that can be written in this, that we have can be written in that form. So let's see how we go about it. um if I By the way, if I were to write it in that form, I'm not going to really use separation of variables. By the way, I don't think I have to use separation of variables for this one. Let me try to determine if it's homogeneous. Of course, I have to write it in the form dy dx is equals to something, whatever that I'm going to have here. Then I'm going to try to determine if it's homogeneous. If it is, I'm going to use these substitutions where I say y is equals to vx, then dy dx is equals to v plus x dv dx. So it's more like I have to make my dy dx the sub of the formula. So what will happen is that I'm going to have y minus x dy is equals to negative 2x plus 2y there dx. So what we do, multiply both sides by what, by multiply both sides by how is that going to be? I'm going to multiply both sides by 1 over dx. I also multiply both sides by what, by y minus x. What I'm going to have is that I'm going to have my dy dx is equals to minus 2, then x there plus 2y divide by, I'll have y minus what, minus x. So now we already know what our dy dx is. It's simply v plus x dv dx is equals to let me expand in advance here. I'm going to say it's minus 2x. Here I'm supposed to say minus 4y, but instead of me using y here, remember to say we are saying our y is vx, so I'm going to put 4 vx there. Put 4 vx at that point. Then here we're going to say divide by where there is y, we put vx minus what, minus x. So this is simply v plus x dv dx is equals to, so you observe to say I can factor out the negative on the numerator, meaning I'm just going to have, like, in fact not just a negative, I'm going to factor out negative x. Okay, so having done that, I'm going to remain with a 2 here, then plus what, plus 4v, like that. Then divide by down here, instead of me having um, oh, I'm also going to factor out the negative x, so negative x like that. Then my v at this point is going to be my v is going to be negative. Okay, that's just going to be more like negative v plus what, plus 1. Okay, plus 1. But I'm just going to write it in this way. Instead of me saying minus v plus 1, I'll say 1 minus what, minus v. So this can go and that can go. So we now have our v plus x dv dx is equals to 2 plus 4v divided by what, divided by 1 minus v, like that. Okay, so I can subtract v on both sides, so that's a 0. So I have like x, I have x dv dx is equals to, I have like 2. Okay, 2 plus 4v. So remember to say at this point it's more like I have a 1, then I'll multiply this by that. Okay, then again I multiply the 1 by everything here, then later on I multiply this one by that one. It's more like I'm putting that as a single fraction, of which I'm going to have like minus v open bracket 1 minus v. Okay, then divide by what, 1 minus v there. So that would be like x dv dx is equals to, what you're going to have is a 2 plus 4v minus v plus v squared, divide by what, divide by 1 minus what, 1 minus v. Okay, so that would be like your x dv dx will be equals to 2 plus 3v plus v squared, divided by 1 minus 1 minus v. So what you observe now is that where I've reached is a point where I can do the separation of variables now. Okay, so at this point we can do the separation of variables. I have like x dv dx is equals to 2 plus 3v plus v squared divided by 1 minus v. So I'm going to multiply both sides by what, 1 over x. I also multiply both sides by what, by dx, then also multiplied by 1 minus v divided by 2 plus 3v plus what, v squared. So you observe to say this will just result in you having something like you're going to have the integral. So it's like at this point I'm doing separation of variables now. You're going to have the integral of 1 minus v divided by what, 2 plus 3v plus v squared dv is equals to, that would be equals to the integral of 1 over x dx. Alright, so now for this part we can break that down into its equivalent partial fractions, and the best way, the first thing that you can do here is just to factorize the denominator first. By doing so, we know to say the product is 3, the sum, the product is 2, the sum is 3. So you're just simply saying v squared plus v plus 2v plus 2. This is simply v. You're going to have your v here plus 1, then 2 here, v plus what, plus 1. That's simply v plus 2, then v plus 1. Okay, so this can be written as 1 minus v divided by your v plus 1, then you're going to have your v plus what, plus 2 dv is equals to integral of 1 over x dx. So if you break this down into its equivalent partial fractions, I'm not going to go through those steps. That is very straightforward. I believe you can do that. You're going to get something like you're going to get 2 over v plus 1 dv when you separate them, of course, then minus integral of 3 over v plus 2, okay, dv is equals to integral of 1 over x dx. What do we then get from that? So what we get here is that we are going to have like 2, like integrating this part, that part, and that part. We are going to get something like for the first one, that would be 2 ln of v plus 1 minus 3 ln of v plus 2, okay, is equals to that's going to be equals to ln of x plus ln of c. All right. So for this part, we can now again remind ourselves of the properties of logs. So once again here I can say ln of that would be like absolute value of v plus what, v plus 1 squared, like that. Then it will be minus that'll be minus ln of v plus what, v plus 2, then to the power 3 there is equals to, here these two you can bring them together, that would be like your cx, like that. Then for this part, okay, for this part you can say that's going to be ln of we are subtracting this one from this one, that's going to be like absolute value of that would be your v plus what, your v plus 1 squared divided by what, v plus what, v plus 2 squared is equals to ln of cx, like that. So this just turns out to be v plus what, 1 squared divided by what, divided by v plus 2 plus 2 to the power 3 there is equals to cx. So this is more like close to the general solution, but remember to say your y is equals to vx, meaning your v is equals to y over what, y over x. You can come here and say while you have your v, that's going to be y over what, y over x plus 1 squared divided by what, y over x plus 2 to the power 3 is equals to cx. Okay, so so now we have been taught to, this is simply like close to the general solution. Okay, this is simply close to the general solution, but for us to find the particular solution, we have x as 1, then we have y as what, y as 0. Okay, so we can do the substitution here for us to find what our c is going to be. So that's simply going to be like you're going to have 0 over 1 plus 1 to the power 2 divided by 0 over 1 plus 2 to the power 3 is equals to c, because our x is 1. So on the numerator you get a 1 divided by, on the denominator is 2 to the power 3 is 8, that is equals to what, c. So meaning c is equals to what, 1 over 8. How then do we conclude this? Okay, how do we come up with a conclusion? So for this one, it will simply mean you have like your y over x plus what, plus 1 squared divided by y over x plus 2 to the power 3 is equals to, where I have c, I'll put 1 over 8, meaning that will be like x over 8. I'll leave it at this stage. You can go ahead and put it in terms of y, and that will be your general solution. I mean, that would be your particular solution. Yeah, having substituted the value of what, the value of c. So let's look at the next example. So for the next example, we are given this is what we are given right here. Okay, so now the question is that what method do we use for that one? Okay, what method do we use for that one? So I observe to say, looking at the form in which it's given, I can use the inter like integrating factor method to come up with a general solution, and then that general solution will help me find the particular solution. So I can, looking at the way it is, I can multiply both sides of this by what, by 1 over x to the power 3, so that I leave the dx on its own here, and that's just going to be like I remain with dy dx. Then here I'm going to have what, 2y divided by what, x to the power 3 is equals to, that would be e to the power 1 over x to the power 2 divided by x to the power 3 there. Okay, So we observe to say, using the integrating factor method, we're going to say our p of x, function of p with respect to x, that's going to be equals to 2 over what? 2 over 2 over x to the power 3. Then our q of x is simply going to be e to the power 1 over x squared divided by x to the power 3. So coming up with the integrating factor, remember to say we use p. So we are going to say integrating factor is going to be equals to e to the power the integral of what? P of x, which is simply a 2. Then here I'm going to put x to the power negative 3 dx. So what I have here and what I have here is simply one and the same thing. Okay, so it's more like, instead of me writing it as 2 over x to the power 3, I write it as 2x to the power negative 3. Simply one and the same thing there. So now what happens here is that you're going to have like e to the power 2, I'll say open bracket, I'm going to have x to the power negative 2 divided by negative 2, because on the negative 3 you're saying negative 3 plus 1, giving you negative 2, and you do the same on the denominator. That's what I have there. Okay, so the 2 goes and the 2 goes, remain with what? E to the power negative x to the power negative 2. Okay, what do we do? This can be written as e to the power negative 1 over x squared, hence being finalized as 1 over e, okay, to the power 1 over x squared as our integrating factor. Okay, so I'll say our integrating factor, we have found 1 over e to the power 1 over x squared. So to find the solution, we are going to say y is equals to the integral of integrating factor, which is 1 over e to the power 1 over x squared. We are going to multiply by the function q of x, which is simply e to the power 1 over x squared divided by x to the power 3 dx. You observe to say this can go and that can go. Alright, so this can also be written as the integral of x to the power negative 3 dx, and we know to say this is just going to give us something like we're going to have x to the power negative 2 divided by what? Divided by negative 2 there. Okay, so we can write this as negative 1 over 2x squared plus what? Plus a constant. So that's what we have as our y. Okay, so that's minus 1 over 2x squared plus what? Plus c. But remember, for us to find the final solution, general solution, you have to multiply the y by what? Integrating factor, which is 1 over 1 over e to the power 1 over x squared. Okay, so that simply means for me to find this in terms of y, I just have to multiply both sides by what? By e to the power by e to the power 1 over x squared. This gives me y is equals to e to the power 1 over x squared by c minus is it by c? Yeah, by c there. Then that would be minus minus e to the power 1 over x squared divided by the what? The 2x squared there. So that's the general solution. So from that general solution, we have to come up with a particular solution. So we're going to say this part, we're just going to substitute. So we are told that y is equals to what? Y is equals to e, then x is equals to 1. So I'm going to put e here in terms of what? In place of y. So that would be my e to the power 1 over x squared. Then we know to say our x is 1. So that's just going to be e here, c minus. We still have what? E here divided by what? Divided by 2. So this turns out to be, we're going to have 2e here is equals to 2ec minus what? Minus e there. Okay, so here is just a matter of making c the sub of the formula. That's going to be 2e plus e is equals to 2ec. So this gives us 3e is equals to 2ec. So we are going to divide both sides by 2e and 2e there, so meaning our c will be equals to 3 over what? 3 over 2. And that's what we have. So meaning the particular solution here, I'm just going to say it's y is equals to e to the power 1 over x squared. Where I have c, I'm going to put 3 over 2, meaning our 3 over 2 here, minus e to the power 1 over x squared divided by 2x squared. Okay, so that this is simply the particular solution that we are looking for the third question. Okay, then for D, okay, going to D, we have like dy dx plus 2xy is equals to xy squared at 0 comma 1. Okay, so at 0 comma 1. So how do we come up with that particular solution for that one? So the method that I'm going to use here is that I observe to say what I have here is is simply a Bernoulli. Okay, so remember to say for a Bernoulli we can write it in the form like 1 over 1 minus n dy, no, that would be dz dx plus what, plus 2xz here is equals to what, will be equals to x. I'm just writing from that one there. Okay, so for this one you observe to say your n is equals to 2. I'm getting my 2 from what you have there. And for our z, okay, we said our z for a Bernoulli, our z is simply equals to y to the power 1 minus what, 1 minus n. So z is simply equals to if you put 2 here, that's going to be 1 over what, 1 over y. That's what your z is. So even at this point we have to substitute. Where you have n, we have to put 2. That will give us negative. So if we're going to have negative dz dx, meaning this has to change, because we are supposed to leave it as positive dz dx. So instead of having a negative here, when you substitute where there's n, we put a 2. I'm going to leave that as a positive, then I'm going to make this negative and that one to be what, to be negative. So having said that, I then say, okay, since I've written it in this form, I can now say, okay, my p of x is simply equals to what, minus 2x. Okay, then my q of x being equals to negative what, negative x. So we can go ahead and find the integrating factor. So integrating factor is going to be equals to e to the like to the power the integral of, I'll put 2, then I'll put x there, dx. That's simply going to give me e to the negative 2, then I have x squared divided by what, divided by 2, which simply give me what, e to the power negative x squared, which is 1 over e to the power x squared, like that, which is our integrating factor. So I can say our integrating factor, we have found 1 over e to the power x squared. So we can go ahead and find what our z is as our solution. Okay, so our z is going to be equals to the integral of the integrating factor. Okay, integrating factor we have, I'm going to write it as e to the power negative x squared, and I don't want to write it as a fraction. So I'm going to multiply it by what, by my q of x, which is a negative x. So I'm going to put the negative outside, then I have x there, dx. So now it's just a matter of us deciding which method of integration works best for such, which is simply u substitution. So u substitution, I'm going to let my u be equals to what, negative x squared. So meaning du is going to be equals to minus 2x dx, making our dx to be equals to negative du over what, du over 2x. So when we come here, okay, and say we have a negative here, so observe to say this negative and that negative are going to cancel each other, and I'm going to have like 1 over 2, then I have like e to the power u, then I have x du over what, du over x here. The 2 I've put it outside here, remember it was 2x. So I'm going to have this x going and that x going, so this will just give me something like 1 over 2 integral of e to the u du. Okay, so now integrating this, our z is going to be equals to 1 over 2 e to the u plus what? Plus c. That's the integral. But I can't use that to come up with a particular solution. No, I have to use the what? I have to use I have to use it in terms of y. I'm having it in terms of z. So keep in mind to say we said our z is equals to 1 over what? 1 over y, and that we are going to multiply that by what? Integrating factor, which is 1 over e to the x squared is equals to 1 over um, 2 e. We said our u was equals to um, negative x squared there plus what? Plus a constant. I have to find what my constant is from that one. So now we are told to say our x is equals to 0, okay, then our y is equals to 1. So at this point I'm going to say 1 over 1, which is simply a 1, okay, just a 1 there. Then I'm going to multiply by 1 over e to the x squared, and I have x being 0, so like e to the 0 is still a 1, so that's just a 1 there. So that will be equals to, so here again you are going to get a 1, so that will be like 1 over what? 1 over 2 plus what? Plus c. So that is your c is going to be equals to 1 minus 1 over 2, which is simply what? 1 over 2. Like 1 minus half is still half. So you can come back now and say you're going to have your 1 over y is equals to, so once again for this one, instead of me multiplying by that, I'm going to multiply everything on this side by what? By that. So it will be like e to the x squared multiplied by 1 over 2 e to the negative x squared plus what? E to the x squared c. But in this case our c is 1 over 2, so I'll just say divide by 2 there. So it's safe to say that can go and that can go. We have like 1 over y is equals to 1 over 2 1 over 2 plus what? Plus e to the x squared divided by what? Divide by 2. So then how then do we simplify that? That's like literally the solution, but I can put that in terms of like making y the sum of the formula. That would be like 1 over y is equals to 1 plus what? E to the x squared divided by 2, making y to be equals to 2 over what? 2 over 1 plus what? E to the x squared, like that. Okay, and that's simply the particular solution for that last part of the question that we were solving. Yeah, and that's how I'll go about solving those questions. Otherwise, thank you very much for the support, and thank you very much for watching.